Hello my dear friends, very good morning to all. So in the last class we discussed about some importance theorem, that is nothing but intelligence theorem, Milliman'S theorem and reciprocating not, it's actually a reciprocity theorem. Okay, so we started doing some problems regarding, and we will continue with the session. Okay, so we will do some more problems so that whole idea will be what concreted more, right? Okay, let's do one more problem. You can write a problem. Please write a problem. Please write a problem. Our question is simply find I. The question is clear to you? Find I. That means the current through 10 ohm we have to find. Okay. Did you find any similar circuit to this same circuit? I mean, did you find any similar circuit like this before? Imagine, try to recollect. Did you find anywhere such a circuit like this? See? Yes. What is that? It is nothing but dual of Milliman's theorem, right? Dual of Milliman'S theorem. Right? Dual of Milliman'S theorem. So what was dual of Milliman'S theorem? So dual of Milliman'S theorem is nothing but if you have so many circuits like, if you have so many connections like a current source in parallel with the resistance, right? Again a current source in parallel with the resistance, right? Again a current source in parallel with the resistance. Again a current source in parallel with the resistance, right? The whole combination is connected in series, right? A whole combination is connected in series. Then the effective value of the whole circuit can be represented like simply what? A current source in parallel with the resistance, right? A current source in parallel with the resistance. Terminal A and terminal B. So, dual of Milliman'S theorem says that if you have a current source in parallel with the resistance, again it is series means another current source in parallel with so many resistors, up to n times you can use that. If you have such value of current, so let be I1, let be I2, let be I3, let be R1, let be R2 and let be R3. So many resistors and current sources are connected in parallel and the whole combination is connected in series. Then the effective value of this total circuit can be simplified to a simple circuit of current source in parallel with a simple resistor. And that value of current source and that value of resistance you have to find. Is it clear? And that value of current source is nothing but, let be R1 or Z1, both you can use. So that current value is nothing but, what was that current value? I already said that sigma I equal to 1 to n into II Zi all divided by sigma I equal to 1 to n into Zi. Is it right? So this is the current value. That means the current, this I can be found out by using this equation. sigma I equal to 1 to n into I1 Ii Zi divided by sigma I equal to 1 to n into Zi. For 3 source, no, for 3 elements, it contains 3 elements, no, into 3 branches, no. That means for n is equal to what? For n is equal to 3. For n is equal to 3, what will be the current value? I is equal to, I is nothing but I1 Z1 plus I2 Z2 plus I3 Z3 whole divided by what is that? Z1 plus Z2 plus Z3, nothing, simple. Is it clear? Is it clear? So, what is I1 here? 1, right? 1. 1 into, what is Z1 here? It is nothing but 1 ohm only, no? Z1 means R and L combination. If it is dealing with AC circuit and only there is a meaning of Z, right? So, it is simply, no, 1 ohm resistance is given. So, it's simply 1. It's simply 1. So, it will become 1 plus, what is I2 here? I2 here. I2 is like that, no? The arrow is towards right for I1, first current. But the arrow is opposite for what? I2, second current. So, you have to use minus 2. Minus 2. Into, what is Z2 here? 2. No issues there. Plus, what is I3 here? Again right side, no. So, no issues there. 3 into 3, right? Whole divided by what is Z1 plus Z2 plus Z3. This is nothing but 1 plus 2 plus 3. 1 plus 2 plus 3. Is it clear? Is it clear? Many cases where there is a chance of what? Faulty, we can take faulty current as simply I equal to 2 ampere plus 2 ampere. So, you have to take care of that. You have to take care of that. Okay. So, this will be of course 1 minus 4 plus 9 whole divided by 6, right? Whole divided by 6. Or in other words, what is that? 10 minus 4 is nothing but 6 by 6. So, I know 1 ampere. So, 1 ampere is the value of what? This current. 1 ampere is the value of what? This current. And you have to find what? That R also, right? That R is nothing but, we have Z is equal to simply sigma I is equal to 1 to n into Zi. Right? Z is equal to what? Sigma I equal to 1 to n into Zi. So, it is nothing but Z1 plus Z2 plus Z3, which is nothing but simply, in the case of this circuit, it will be nothing but R1 plus R2 plus R3, which is nothing but 1 plus 2 plus 3, it is nothing but 6 ohm. 6 ohm. So, now you have a single current value and a resistor R, right? A resistor R. So, this up to this circuit, right? Up to this circuit can be replaced with what? A current source of 1 ampere in parallel with a resistance of 6 ohm, like this. Okay, let us redraw the circuit. Where is my resistor? Okay, it is here. So, I have a problem of cold, that's why sneezing sometimes, no? Really sorry for that. Really sorry for that. So, let us redraw the circuit, right? Let us redraw the circuit now. So, it will be, see, up to this portion, right? Up to this portion can be replaced with what? A current source in parallel with a resistor. A current source in parallel with a single resistor. And that current source value, that is nothing but this I, 1 ampere. Is it right or left? That is very important. This I is right or left? If this I is negative sign, then it will be left. If this I is positive sign, it will be right. So, it will be 1 ampere right, 1 ampere right. Very important, beta. Very important. This concept you have to firmly insert in your mind. Firmly insert in your mind, because the direction is very important. Otherwise, the problem will be wrong. So, R is equal to what? 6 ohm. So, it will be 6 ohm. 6 ohm. It will be 6 ohm. And up to this portion only we have replaced. There is 10 ohm as a load, no? There is 10 ohm as a load. So, how can we find that 10 ohm, right? So, see, and this whole combination is connected actually. across this 10 ohm. And it is given in the question that through this 10 ohm the current is in this direction. That means in this direction the current is in this. That we can't alter, that we can't change, because it's already given in the question that the current is in this direction. That we can't alter or change. Okay, so see, the 1 ampere current is entering here and it came here, right? And it have two paths like this, right? Let I am taking this as I1 and let it be I2. See, any current which is entering to a junction which is split up into two, right? So this current is something like this and this current is something like this. Let be I1 and I2. Then I have to find what is I2 first. So what is I2 now? So use current division rule here. So I1 ampere is the entering current, right? So the current I2 will be nothing but the entering current 1 ampere into opposite branch resistance, that is nothing but 6 ohm, whole divided by total resistance, which is nothing but 6 plus 16 ohm, 3 by 8 ampere. I2 is equal to 3 by 8 ampere. So the answer is over. So this is the answer. Is this the answer? No. Because the current I, but I will be equal to minus I2. Is it clear? Because this I2 is in this direction. That is not we want to find. We want to find that I with a certain direction which is given in the question. That same I we have to find. There the question, what? Carefully do the question. No, carefully you have to do the question. Is it clear? So in the very tough exam, if the exam is very tough, then a problem will be asked like this, and there is an options both of 3 by 8 and minus 3 by 8 So you have to take care of that. Whatever which is given in the question, keep the elements and keep the direction like that. That according to that direction you have to find the answer. That is the main thing you have to notice. Otherwise the problem will be wrong. The answer will be wrong, no? So, but I is equal to what? Minus I2. That means which is equal to what? I is equal to what? Minus 3 by 8 ampere. So this will be the final answer. 3 by 8 ampere is not the final answer. And minus 3 by 8 ampere is the final answer. That is you have to keep in your mind always. So this is very good question actually. But answer is, you can solve answer in very 2 or 3 steps. But you have to take care of the direction. Otherwise the answer will be wrong. Okay, let's check the answer. Yes, it's minus 3 by 8. Is it clear? Beta? Is it clear? Okay, let's do another problem. I think it's very clear to you. There is not at all doubt. So you have to take care of the circuits like what Milliman'S and dual of Milliman'S theorem. No, you have to identify the circuit first, whether it is comes under Milliman'S or whether it is comes under a dual of Milliman'S. You have to identify. Then only it will be easy. See, this problem can be solved in many ways. No, many ways you can solve this problem. But the simplest method I have chosen. Okay. See, let's see the next problem. So our aim is simply find I. Find I bus. Find I bus. Find I simple. Okay, how can we solve this? How can we solve this? So if you find a question like this, first thing you have to keep in your mind that the theorems, the shortcuts. So this problem can be maybe do with many other ways, but you have to if you know clearly what reciprocity theorem is, then you can find it in single step. You can find it in single step. That is the peculiarity of that theorem. So you have to, but always observe with the problem, and if you find any theorem that we studied suitable for it or not, that is the first thing you have to keep in your mind. So by simply looking in the problem, reciprocity theorem says there should be only one source, no? For a single source element only, that theorem is valid, okay, and it is not valid for independent source, not dependent sources, right? It is not valid for dependent sources. That means if the source is in the nature of like this, no, like 2v x or like that, no, that is called the dependent source. That means the value depend upon any other parameter in the circuit. That is a dependent source. So reciprocity theorem is not valid for what? Dependent sources. But this is nothing but an independent source, no? 10 volt and 30 volt all are independent sources. So you can simply go for what? Reciprocity theorem. So apply reciprocity theorem. Apply reciprocity theorem. What is that? See, the ratio of excitation to response is always constant in a circuit. That is called in a what? Single element circuit or single source circuit. That is called what? Reciprocity theorem. Of course, it is what? The sources should be independent in nature, right? So the excitation is nothing but 10 volt and the response is nothing but 2 ampere, which is equal to here the what? Excitation is nothing but what? 30. Is it 30? No. Is it 30? No. It is minus 30. It is minus 30. And response is nothing but what? I, simply I, no issue there, no issue there. Because you have to always it's compare with the standard circuit. What I said for standard circuit, if it is a network and this is V1 and this is I1, and if it is a network, this is V2 and this is I2, right? This is I2. So this standard circuit, no, for this standard circuit I explained what? That is reciprocity theorem. V1 by I1 equal to V2 by I2. So anything which is what? All change with this circuit, if the current direction is opposite to that this direction or the voltage is opposite to that of the circuit direction, you have to add a minus there. You have to add a minus there. So it is nothing but minus 30 divided by I. There is no change in that because in this circuit the I is there flowing in the downward direction. No? So then there is no change in that. So what will be I now? So it will be 5, it will be 6. So I will be minus 6 ampere. I will be minus 6 ampere, which indicates that the current direction is not like this in the real answer. It is like this. It is like this. Opposite direction minus. That is why the answer is in minus form. The minus indicates that the assumed direction of current which is in the question is not exactly the true direction. The true direction will be what? Upward direction. Upward direction. Is it clear? Is it clear? Okay, that's all. So this is what reciprocity, simple theorem. It's actually very simple theorem, but you have to apply accordingly. You have to apply accordingly. So let's do some more problems regarding this reciprocity theorem. Then only, no, this is very simple problem, no. You have to do some more difficult problem. Some more difficult. Okay, write down a question. Write down a question. So questions like this will be asked in your examination. Okay, we have to find the value of I. The question is nothing but find I. Find I. The question is nothing but find I. How can we solve it? How can we solve such a beautiful question? Such a beautiful question. See, in your RRB JE exam or RRB SSC, SSC JE or RRB SSC, any examinations like problems will be there, but that all will be not long problems will be asked for such type of examination, but short problems. But you have to utilize your brain. You have to think, and the first step itself or first look itself, you have to identify which theorem is applicable for that question. Then only that will be solved within the span of 1 minute. Otherwise, it will take a long time. You can't solve for that. Okay. See. So, sorry. There are two circuits. No, there are two circuits. One is single 5-volt source and 1 ampere is a current. And other one there are two sources. And we have to find the value of this I now. There is no value of this R, simply it is R. If it is some value, then you can easily find, you can use many alternate methods. But it is not there, R is simply R itself, so it's slightly complicated. But this can be solved by using reciprocity theorem as well as superposition theorem. Combined form. It can be solved with reciprocity plus superposition principle. Two theorem can be applicable here in order to solve such a problem. Let's see how it is. See, I have to take case 1. So in my case 1, what I took simply, 5 volt. This is 1 and this is R, this is 2 ohm, 5 volt. So, for case 1 it is already given that. What is that? It is like the same circuit. So, here the source or excitation by response will be equal to what? Excitation by response will be equal to 5/1, no issues there, 5/1, right? So, I am going to take case 2. In case 2, see, my circuit, I modified the second circuit as see what I did. In case 2, I only used this 10 volt source. I didn't use this 5 volt. I used this 5 volt. Second case I use only 10 volt. First case I use only 5 volt. Actually, this is our final circuit now. This is a hint circuit actually. This is the final circuit. If there are two sources exist in a circuit, you have to find the value of I here. And this is the hint circuit. So we already studied that if there are two sources exist in a circuit, we can solve that by using superposition principle. Superposition principle is nothing but what? The algebraic sum of the effects due to individual sources. That is the final result, right? First you have to consider 5 volt, remain this side short circuited. So you consider like this. No, first you have to consider 5 volt, the circuit short circuited, and it is already given. Next you have to consider this 10 volt, keeping this 5 volt short circuited. That is I draw here. What is that? I have chosen this 10 volt only and keeping the side short circuited and marked that current as I2. Now I have two circuits. Clear? So, according to what? Reciprocity principle, the ratio of source to excitation is always constant, right? the ratio source to excitation, or the ratio of excitation to what? Response. The ratio of excitation to response is always constant. Here the excitation is 5 volt, the response is 1, so 5 by 1. Here the excitation is what? Minus 10. So now here what is that? Excitation divided by response will be nothing but minus 10 by I2, right? Minus 10 by I2 in like previous case. So according to reciprocity principle, right? That means according to reciprocity principle, let be equation number 1, let be equation number 2, 1 and 2 equal, right? 1 equal to 2, according to reciprocity principle, 1 equal to 2, that means 5 by 1 is nothing but minus 10 by I2 or simply I2 equal to minus 2 ampere, I2 equal to minus 2 ampere. That means this circuit, I mean this circuit now, in this circuit, this I2 is nothing but what? Minus 2 ampere. So the modified case 2 will be, so we can write like modified case 2. Modified case 2 diagram will be what? Modified case 2 diagram will be what? Modified case 2 diagram will be see, it is given as minus 2 ampere now, but I2 here it is taken like this direction. If it is minus 2 means the I2 will be like in this direction, 2 ampere, 2 ampere. If this is 2 ampere means this is 2 ampere, right? This is 2 ampere, right? This is 2 ampere, right? If suppose there is a current like no, if the current is X, if it is 2 here, then no, it is flowing through 2 ohm. The same 2 it's flowing no. I mean this current is split up into 1, 2. This current is split up into 1, 2. This is also 2 ohm, this is also 2 ohm. That means this current also 2 ampere. Or this current will be what? This current will be what? Beta, it is 4 ampere. It is 4 ampere. It is 4 ampere. Is it clear? Is it clear? And this is nothing but 4 ampere. That means this current is like flowing like this. This current is flowing like this. Is it clear? Is it clear? And if you use this circuit, that means this is our final circuit no. If you see this circuit, it contains 2 sources and we split these 2 sources into single source no. In case 1, first source only exists, and in case 2, second source only exists, and we found out, but in both the cases the current value no, the current value. In this case we find current value like this, and in this case we found current value this way. So in both the cases we found the current value, right? In both of the cases we found the current value. So if the 2 sources exist together, what will be the result? The result will be the algebraic sum of these 2 currents, right? The algebraic sum of these 2 currents. That is how the superposition principle says. What is superposition principle? It says that whenever 2 or more sources exist there in a circuit, the total response will be, which is across any element, the total response will be the algebraic sum of the responses due to each element or each sources. That means it is the algebraic sum of responses due to 5 volt, that is nothing but 1 ampere, and another 10 volt, that is due to 4 ampere. So we have total current I will be nothing but, both are in right direction no, right side direction no, it is, so it can be added, so it will be 5 ampere. So this is the final answer. This is the final answer. This is the final answer. Let's check the answer. Let's check the answer. Correct. So you have to observe the problem. You have to concreted concept of theory. Then only it can be solved. then only it can be solved easily. Otherwise, you may stuck somewhere. That is why I repeatedly saying, please revise whatever you studied in the last class. Please revise whatever you studied in the last class. I'm going to say a clear-cut thing. A technical subject now, electrical and electronics engineering, full. If you cover the full subject, it contains all the subjects, machines, power system, all that subject. You can't clear it for within a span of 2 months or within a span of 1 month or 3 months. At least you need 7 months. 7 months dedicated study, then only these things will be keep in our mind. Otherwise, it's almost it is something like cheating the subject. If you study for 2 months or 1 month, you may feel that it can be easily. I know this. It's wrong actually. You can't go for that. That means even if you study for that 2 months, and you found that you completed the syllabus, at the time of examination, you will be definitely stuck. So it needs dedicated study of 6 to 7 months. At least you have to spend 2 hours per day. You have to spend 2 hours in a day. Then it will be covered within a span of 7 months. Okay? So let's do a next problem. I'm taking it very, very slowly, slowly, because you have to clear the concept. That's why. Because there is no hurry for me, there is no rush for me, because the exam date hasn't announced. So no need to make it rush. Okay? So let's do another problem. So again you have to find I. Okay? How can it be solved? How can it be solved? Observe the circuit. Please observe the circuit. How can it be solved? See, again you can apply both the superposition as well as reciprocity theorem here, no? Both superposition as well as reciprocity theorem here. How can we apply that? Again for case 1, no? Case 1. You have to consider a single source. 5 ampere. You have to consider a single source now in case 1. So consider a single source of 20 volt and 2 ampere current is flowing. But in figure B, it is given that it is not 20 volt in the input side now, it is 40 volt in the input side. And see, if for 20 volt the current is 5 ampere means, what will be for 40 volt? Of course, it will be double. Proportionality theorem now. homogeneity principle, no? So it will be, so in case 1 itself you can draw another figure like, for 40 volt figure, it will be like 5 ampere, and it will be like 4 ampere. It will be like not 5 ampere, it is 10 ampere. It is 10. It's 10. That means in the question it says 40 and 60, no? So you have 20 to 2. For 20 volt it is 2 ampere here and 5 ampere here, means for 40 volt it's 10 ampere here and 4 ampere here. Oh, there is no doubt. So this is the case 1 case. This is a case 1. So here now we have excitation to response is nothing but what? 40 by 4. 40 by 4, right? Excitation to response is nothing but 40 by 4. Clear? Now we have to consider case 2. Case 2. In case 2, see, so I have chosen only one source and keeping the second source short circuited, and next we have to use the second source. Keeping this as, let it be I or I2. Keeping this side what? Short circuited. Keeping this side short circuit. By looking the figure, this and this, you can compare these two figures. Here is only one source and there is a response. Here is only one source and the response. So according to reciprocity theorem, so by reciprocity theorem, this can be right, no? By reciprocity, here the excitation response is what? Here the excitation divided by response is what? Excitation is nothing but minus 60, response is nothing but I2. So excitation response is minus 60 by I2. So by reciprocity, let be equation number 1 and let be equation number 2. 1 equal to 2. 1 equal to 2. That means we can go for like 40 by 4 equal to what? Minus 60 by I2, or simply it will be minus 6 ampere. I2 is equal to what? Minus 6 ampere. I2 is equal to what? Minus 6 ampere. Minus 6 ampere. But I2 equal to minus 6 means the original direction of the current will be in this circuit. In this circuit, the original direction will be what? The original direction will be like this. So the new circuit will be, original circuit will be what? So this is the I2. So this is the I2, original I2. It is equal to 6 ampere. So in the original figure, we have to find this I. We have to find this I. That means in the first case, if 40 volt alone exists, this is nothing but what? 10. That is also toward right side direction. In second element, in second source, 60 volt alone exists. 60 volt alone exists. The current is in again right side direction with 6 ampere. So the effective current will be by superposition principle, effective current will be equal to, this is right side current now, so you can take it in a what plus. This is also what? Right side current, but it is 16 ampere. Is it correct? In the question it is given that the current is in this direction, means we have to find this current. We have to find that current. That current will be but I will be equal to minus 16 ampere. That is the answer. That current will be minus 16 ampere because that current is opposite direction. For this circuit it is 10 ampere this in right side direction. For this circuit I2 is in right side direction. I2 is in right side direction. Clear? But it is given in the question, it is in reverse, opposite direction. It is in left side direction. That I will be minus 16. Effective current will be of course 16 ampere, but we have to find that current I first. So that I will be minus 16. That I will be minus 16. So if the examiner wants to really check your knowledge, if the examiner wants to really check your knowledge, definitely he may have an options like one option is 16, another option is minus 16. Definitely you will be confused. Definitely you will be confused. And the answer is nothing but what? Minus 16. Is it clear? Let's check the time. Let's check the time. 42. Okay, time is there. Time is there. Time is there. Is it clear? Is it clear? It's very, very what? Easy, but you have to really know the concept. You have to really know the concept. Then only it will be easy for you. Otherwise, it's a very difficult problem. It's a very difficult problem. So you have to know both the reciprocity as well as the superposition principle, and you simply don't know, but simply if you simply knowing what is reciprocity, what is superposition, you can solve. You have to clearly feel the theorem. You have to clearly feel the theorem. Then only it can be solved. Then only it can be solved. See? Okay, let's do another problem. Let's do another problem. Let's do another problem. See? You can draw it somewhere beautifully. Beautifully. Yes. So now you have to find that I. How can we find that I? How can we find that I? And one more thing, it's 20 and 5 amperes. 5 amperes. How can we find I? How can we find I? See, this also you can solve it with the reciprocity theorem, no doubt in that. So, but a thing you should note that here it is not short circuited. Reciprocity theorem always apply when there are no output side is open, short circuited. Then only you can apply for that reciprocity and all, right? So you can't directly go for reciprocity here. You can't directly go for reciprocity. But you can find another way. See. So see, here it is also to excitation, means in figure A, from A, source to response or excitation to response, anything. 20 by 2, right? 20 by 2. If you go for the circuit from B, if you go for a network like this, if you go for a network like this and let be marked at ISC, let be marked, I marked this as ISC, then also you can find ISC, no? Then also you can find ISC, no? By comparing these two circuits, source to response will be, or excitation to response will be always constant, right? So what is ISC here? ISC nothing but, here also in this diagram also, excitation to response means, excitation by response here is 60 by ISC. So according to reciprocity theorem, what I can write? 20 by 2. So according to reciprocity theorem, 20 by 2 will be equal to 60 by ISC, right? So ISC will be what? 6 ampere, right? ISC will be what? 6 ampere. That means you have a circuit like this and its ISC is 6 ampere. Its ISC is 6 ampere. That means if I open this terminal, right? If I open this terminal, what I feel, if I open this terminal, see, let it be represented like R Thevenin. It is 60 volt. It's 60 volt. If I open this terminal and again the 60 volt as constant, there symbol, only after solving all problems, no, solving full, you will get the idea. Until wait, okay, until wait. If I open this and if I apply the same voltage here 60 volt, then this R Thevenin is there, and that R Thevenin is nothing but see, in the first figure, these two figures are connected, right? Of course, in the first figure, the input voltage is 20 and the input current is 5 ampere. So input voltage divided by input current will be the resistance offered. That means when you look from here, you feel a total resistance of 4 ohm. You look from here, you feel a total resistance of 4 ohm. That means R Thevenin is equal to 4 ohm. That means this circuit can be represented like, see, ISC, that means in parallel with R Thevenin. Is it correct? This circuit can be represented like ISC in parallel with R Thevenin. That is nothing but Norton theorem. I did simply apply Norton theorem here because it is 8 ohm here. You can't directly go for that superposition or reciprocity theorem there because it is 8 ohm there. If it is not 8 ohm, it is 6. Directly short circuit means you can directly go for that reciprocity. There is no issue there. But it is not like that. It is 8 ohm there. So first you have to remove that 8 ohm. And short circuited terminal and find the value of short circuited current. First step. You remove that 8 ohm and open circuit it and look from that side and find the value of what? I mean Thevenin resistance there. Find the value of Thevenin resistance there. This circuit is similar to this circuit. No issues there. So only way to find Thevenin circuit if it is open there. If it is open, there is nothing but the voltage by current, nothing but, because this network is nothing but this network, no issues there. Only source and excitation can be, response and excitation can be changed. This network, both network are same. That means whatever elements contained in this circuit is same in this circuit. Or what manner it is connected, same manner it is also connected. That means if it is R Thevenin means this network contain also R Thevenin, effective resistance. Is it clear? You can't say that this is network 1, another network is this. No, it is same network. That is why network. Otherwise, network 1, network 2, no. If it is same network, no, that is why network. If it is another network, network 1, network 2 will be there. It is not like that. So it is same network. So for same network, the resistance offered by the current will be same. That means the resistance offered by this side, no, input side is nothing but voltage by current. R equal to V by I, so it is 20 by 5, that is equal to 4 ohm. That is the open circuit but resistance. That is nothing but Thevenin's resistance. Or Norton resistance, R Thevenin or Rn, both are same. Because we already studied that. In Thevenin theorem, you simply take it as R Thevenin. In Norton theorem, it is Rn, but both are same. RTh equal to Rn, because the way in which we find both are same. That's why it both are same. So this is the effective of this circuit. No, this can be represented like this. This can be represented like this. But actual circuit is not like that. Actual circuit, there is one more thing. It is 8 ohm. In actual circuit, there is one more thing. It is 8 ohm. That means this thing can be what? ISC. What is ISC? 6 ampere. 6 ampere. What is R Thevenin or Rn? What is R Thevenin or Rn? It is 4 ohm. Right? We have to find the current here, I. That is our aim. We have to find I. That is our aim. We have to find I. That's our aim. So what is I? 6. That is the incoming current, right? 6 into 4 divided by 12. 2 ampere. Let's check the answer. Yes, correct. So that is the concept. It is, I know it's a very difficult question. I know that. But up to this problem, if you can do, exam will be very easy. This much difficult question will not be asked. This type, it is gate standard question. This type of question is in gate standard level. This cannot be asked in your SSC, JEE or like examination. It cannot be asked. But if you solve up to this, then below that problems we can easily solve. What is the time now? Okay, my time's up. Okay, so that's all for today, and let's continue with some more problem in the next class. So until then, a very goodbye to you all, and please share this video if you really like it. If you found it is really worthy in watching, please share to your friends, because many of your friends are there who cannot pay a very huge amount for taking a course from online or offline. For that type of students, it is very useful course. It's very useful. My intention or my aim is simple: correct knowledge to poor people. Correct knowledge to what someone is there who really thirst for knowledge, then this knowledge should be delivered with free of cost, because they can't pay much more. Many are there in our country. So that's my aim. Actually, my mother tongue is Malayalam. Why I took it is in English means it should cover pan India. Many countries or many villages are there. Not countries, actually many villages are there in India where no tuition classes, there is no coaching classes. So for all them, it will be a help. That's my intention. So please share to all of your friends. Maximum share. You please do. Okay. So thank you so much. So bye.